Hello everybody, ladies and gentlemen, welcome to Timway Presents here on Twitch. And I've just returned from an absolutely awesome game of badminton. So after this physical exhaustion, I'm now ready for some mental exhaustion. Uh, so let's take a quick look at what we're going to do today. See, the reason the 3D maze manual is right here open on the screen is because I added rule seat support to it. Right, souvenir is not really what I'm doing today, but that's okay. So I added rule seat support to 3D Maze, and there is another module that I really want to add rule seat support to, because one of my favorite algorithms in KTANE has been an algorithm to generate mazes. So we are going to tackle Mouse in the Maze. Alright? So let's tackle today's task tenaciously. Timwee. Here we have the 3D maze code. Let's switch over to Mouse in the Maze and let's open it in Unity as well. Alright, so I see we have a few viewers today already. Hello Livio and hello Marks, and welcome to the stream. I'm so happy to see you all. I'm so glad that what I do shows... Hello, Trax Josh. I don't think I've seen you on this stream before, or anywhere else. Do I know you? I'm sorry, I'm not implying that I need to know you. I'm just curious how people find out about me and my stream. Right, so let's see if we can... Ooh. This is a bit weird. Well, anyway, it doesn't really matter. So let's just click here. Ooh, this is also a bit weird. Let me just quickly make sure that this module actually works on the bottom. Oh, now that is very interesting. It seems that the module is actually broken. The object you want to instantiate. Oh, okay. Okay. Looks like I need to start with some debugging here because there is a missing mesh. The highlight for the left button is missing its mesh, and why would that be the case? So in order to to figure that out, we're going to take a look at the revision history. It seems that a few things here have changed, but this is all just changes in the mod kit, in the test harness, so that shouldn't matter. Let me just quickly take a look at the history. Change the camera clipping plane so that it works better on large bumps. That seems like a reasonably innocuous change. And of course some modkit updates. Let me take a quick look at the actual modkit. I guess I want to undo this. And right. So here's what I'm going to do. I'm going to tentatively submit all this, and then I'm going to revert to the previous version. Oh, come on. Let's go to Mouse in the Maze, and what was it called? KTANE MK, right? Let's fix that. Stage all of that, and let's make a commit, and then let's undo that. So I'm going to, you know what, let's create a branch, experiment or whatever. I don't really care what I call my branches. Let's go here, reset current branch to this commit hard. And now let's see what Unity has to say about that. Hold on, compiling, importing. Lots and lots of stuff. Yes, I do want to reload things. It doesn't look any better. In fact, now it doesn't even compile. Are you missing an assembly reference? Oh my word. I had no idea that Mouse in the Maze... Whew, I was not prepared for this. But I'm going to figure this out if it costs me the rest of the evening. Alright, let me just quickly have a quick snack. Okay, so restarting Unity hasn't helped. Oh, okay. Okay, I see. Reverting the changes has removed some of the directory junctions. So at least the compiling should work. Now I'm getting even more errors. Oh my gosh. I'm lost right now. I'm especially lost for words because I had no idea that things were... Oh, I see. I need to revert all... Because this is the actual modkit, not Mouse in a Maze. I need to revert all of these things in order to restore all the missing script files. Right, now, at least the compiler errors should disappear. Alright, this is gonna take a while. And here was I thinking that I would just breeze through this. Okay, so at least the compiler errors have disappeared. The module is still broken. Let's see. Edgeware configuration. Ah, okay, so maybe... Oh no. And now Unity is frozen. Are you telling me that there's an infinite loop in here? Wow. I'm being hit by the biggest flurry of problems I've ever encountered. I'm going to have to kill Unity. Which is unfortunate. But, we can always just start it again. And this time, instead of running the module, we can take a look at the, Okay, so it said edgeware configuration, so I'm wondering if the problem had something to do with the setting, but it doesn't, because it says none. I thought there might have been an invalid edgeware configuration there. Okay, I'm going to risk it again. I'm going to run it again. Alright, this time at least it responds, but it's still broken. And I'm so confused about that. Let's see. Okay. You know what? I have an idea. I'm going to delete the junctions. I'm going to revert the entire repository, or rather the entire directory, whatever you want to call it, back to what's actually in the Git, in the Git repository. Right. And I believe there are 2 directory junctions here. Let's remove those, like that. And now, git reset head hard. And let's see the git status. Let's git clean -xfd, I believe, was the command. Oh, okay, I probably should have closed Unity before doing that. Can I please close? Oh, Unity is probably asking, yeah, force quit. I don't care. Yes, try again and do it again. Okay. Git status once more. Okay, right. And so now we have a completely clean commit. Of course, it's one of the older commits, right? But I must have uploaded one of these older versions to the workshop, and they must have been working. So, wow, I'm just really speechless right now as to the amount of problems that I'm running into that I didn't expect. And here was I thinking this would just be a breeze. A spinning wheel. Oh, yeah, I think I'm gonna use the wheel for souvenir. I think for rule seed support I need I mean, I don't really have any. I don't really have a list of modules that could benefit from rule seed support. Oh, is that what the problem is? Okay, I remember this. Okay, so what's going on here is that we upgraded Unity to this version 2017.4.22 F1 at some point, because you know the game, the actual KTANE was updated to this version. But there is a bug in this version which causes it to not work with Blender files in some circumstances, and I don't know the proper fix for that. And unfortunately, Mouse in the Maze heavily depends on a Blender file. Like every part of Mouse in the Maze, including the actual walls for the maze, as well as the the buttons on the module, they're all in a Blender file. So I need to find a solution to this before I can continue. Right, and this is not gonna, this module is not gonna work or not gonna show up until I've figured this out. So, let's see, Unity 2017.4.22 F1, Blender import problem. Let's see, problem with importing blend files. Okay. Let's see what the answers are. There is no answer. Great. This just finds me people with the same problem. Okay, so this is just a specific problem within Blender. Yeah. This is not the same issue, and it's also not the same version, because you may have noticed that right here it says that the version number is not mentioned on that page. Can't import blend file. Looks like I've already seen this page before because the link was visited. Let's see. Link for Blender Direct Setup. Let me quickly check if I already used that. Ooh, that's a different version, I see. After opening file in Blender, go to File Export FBX, and if you get problem in model axis orientation before saving file, there's an option. I guess I could try that and see if that fixes anything, but this is really not the live stream that I was envisaging. So let's wait for that to finish downloading. Maybe I should also remove the other version of Blender, because I'm now installing a an older version. So let's uninstall this one. Yeah, of course I have Blender installed, Livio. I've been doing modding for KTANE for long enough. If I didn't have Blender installed, I think I would have had a problem much longer ago. So I think that that probably finished. So let's go here. Let's quickly scan this with Windows Defender. And no, that was not an advertisement. I'm not a fan. This is not a product placement. I'm just scanning the file. That's all I'm doing. This is taking longer than I expected. Right, okay, thank you. And let's run that. Right, I accept these terms of license agreement, right? Let's put that. Would you want to bet, yep, that this folder still exists because it just never cleans itself up properly. Next, install. Okay, so while that is installing, let me take a look at this. After opening file in Blender, go to File Export FBX. But let me quickly check what format that file is in right now. It's actually a .blend file. Okay, so now that I've reinstalled Blender and I've installed a different version, I'm just quickly going to try and see if that magically fixes it. But if not, then yeah, it seems that it hasn't fixed it. This is still. Let me re-import this. Yeah, that doesn't seem to do anything. Ooh, oh, that actually worked. Oh my word. No, not all, not all. I don't want to reopen everything. Just re-import this, please. Okay. Fingers crossed. Okay, it is working, or at least some of it. I mean, the whole BOM is not there, but that's probably because the test harness has not been updated. So now that this works, whew, that was quite daunting. So I'm going to go back to the master branch right here. Okay. And of course it complains because there are some files. Yeah, okay. So let's just quickly close Unity. Okay. And let's git reset head hard and clean everything, and then switch to the master branch. Yes. Okay, so now I've switched to the master branch, so git status should now be empty, and now it will re-import everything because, you know, this git clean command cleans everything, including the library folder, which is where Unity saves all of the stuff that it does now. So it has to do all of that again. Alright, so while it is doing that, let me just very quickly show you what I did last time when I did the 3D maze rule seed support, because there are actually two things to it. One of them, of course, is the actual maze generation algorithm, which is right here. No, which is, well, it's somewhere. But anyway, the other thing is this sort of creating an SVG from a maze, because I know that I use that exact same algorithm to generate this very manual. Right? This manual used to be it had bugs in it, and I fixed it. In particular, this maze in the bottom right corner actually had 2 squares or something that were unreachable because they were completely walled off. And so I wrote this algorithm, which I used both to regenerate this manual and also to create the embellished version of the 3D maze manual. And now that I have that algorithm, I'm just going to keep reusing it. Alright, so let's see if Unity cooperates now. Okay, so this looks like it's the newest version. Let me quickly take a look at the mod kit. Yep, that is all. Oh, I see. It's because I removed the directory junction, so it's not coupled to the mod kit. So how about this? Let's create all these directory junctions again. I keep forgetting the name of that batch file. Okay, that seems to have been correct. Okay, and that made no changes. Very good. That means that everything was up to date. I mean, virtually no changes. Like, I don't know why there is this modules.meta file, but whatever. Okay, so it just re-imported the files, but they're the same file, so it should have made no difference. Okay, so let's just quickly commit that as well. And later, when I'm done, I will merge these into one. You know, actually, maybe I should merge these now and call this a modkit update. Yeah, that's what I'll do. So let's just take the last 2 commits from here, merge them, and reword this one. There you go. Okay. Why do I... Oh, because it keeps doing this. Okay, fine. Fine. Oh my gosh. So git reset hard head. Let's do that again. And restore everything. Yes. Okay, git status. Alright, now other things have changed. Oh my gosh, things keep changing. Alright, fine, whatever. Let's just... What are the changes even? It changed the version number on the solution file. Why does it need to do that? I don't know. Right, let's just commit that again, I suppose. Oh, wait. We're in the middle of a rebase. I need to cancel the rebase. Abort. That's what I'm trying to do. Okay. Right, now let's take a look at the git status. Okay, now it's clean. Now I should be able to do this. Right, reword that and then fix up that. Okay, and we're just gonna call this a modkit update. There you go. Let's just call it that. And now finally we have a change in here called modkit update. And while I'm at it, I might as well just push it so that it's on GitHub, safe and sound. It's taking longer than I expected. Okay, so I guess I can close this file, this window rather. Okay, that is completed successfully. And would you want to bet that there is some changes? No, there isn't. Okay, so Unity is... Oh, Unity is not done with its importing. Hold on. Yes, I am holding on. Okay, let's look at that. Okay, everything is clean now. Phew. Alright. So now we can finally start working on this. Okay, so let's take a look at the source code for Mouse in the Maze, which for some reason is called maze_3D. But you know what? Maybe since I'm the maintainer of this, I might as well actually change this. Mouse in the Maze module. I can always change that and have Unity just regenerate the solution file. And okay, let's see. I want to discard. That's what I want to do. Thank you. Okay. Now I need to figure out where in this file the maze is actually defined. And I strongly suspect that it's probably somewhere in a... there we go. Right, it's just a long list of Boolean... Right, so these arrays, these Boolean arrays right here, this one and that one, they start out with all values set to false, and then the ones that are walls, I presume, are set to true. So now one thing that confuses me a little is that this one says 10, 9, and this one also says 10, 9. Right, since this is a 10 by 10, let's close 3D Maze. Since this is a 10 by 10, 2, 4, 6, 8, 10, I would expect the horizontal walls to be 10 by 9 and the vertical walls to be 9 by 10. So it's possible that vert walls is actually, you know, back to front. So let's actually take a look at this here. Like, okay, this is where we render it. I want to check where, okay, let's find out where the buttons are pressed. So where we have an on interact handler. So here, there we go. Okay, so that will play a sound. It does not do an it does do an interaction punch, but only if it's not solved. I don't know, maybe it should do this. Well, it doesn't matter. Okay, so let's see. So 0 is the submit button, so it checks if the goal position is the correct one. Okay, so 0 is actually the goal color, I guess. But it's the position of the correct sphere, and then we check what I see. Okay, so that's that. Right, now let's see here. Move forward. See, it is exactly as I suspected. The x and z coordinate, apparently it uses x and z, are swapped in the vert walls array. That's okay, I can deal with that. I think I'm going to keep it that way, because to change that around is going to be quite a lot of work, and I'm probably going to make a mistake somewhere. So I'm not going to do that. So instead, I'm just going to write some code that will generate a new maze. Now, here's something that I want to do. Now, it's actually quite convenient that I have this list of walls. I want to count how many of these walls there are. Hang on, is this... Oh, I see, this is just for the first maze. Okay, so let's count how many walls are in the first maze. The first maze has 79 walls. Okay, why am I counting these? Well, you see, if I generate a normal maze, a spanning tree maze, where every square is reachable from every other square in just one way, then it will always have the same number of walls, because you take out exactly one wall for every square, right? And these mazes, the mazes that we have in Mouse in the Maze, are not spanning tree. Oh, maybe they are. Wait a second, I haven't even checked if they are in fact spanning tree mazes. Okay, so a spanning tree maze means that it doesn't have any loops in them. And as I look at these, it does seem to me that they don't actually have any loops in them. It's amazing that I never really, that I was not confident that I knew this. Oh, look at this. The fourth maze definitely has a loop in it. But the first two do not. Oh, no, there is a maze, a loop right here. Right, let's keep going. So this is maze number 3, which we've already calculated. So I suspect that the number of walls in these mazes is going to be the same for all of them. Oh, and it is not. This one has 77. Okay. Two more to go. Number 5. Let's replace that. And that is 77 as well. And then number 6, right? There are only 6, yes. I think we can close this. Thank you. Right, so maze number 6 is this one, and it has also 77. Okay. Now, how many walls would a spanning tree maze actually have? Well, we have 100 by 100, which is, whatever, Tom. We have 10 by 10, which is 100 cells. And, right, yeah, of course. So we have 10 by 9, which is 90, plus another 90, which is 180 total walls that it could have. And it will remove 99 of those. So 180 minus 90 and then minus 9. So a spanning tree maze would have 89 walls. So we're approximately 10 walls short. So what I will do is I will write an algorithm that will generate a spanning tree maze and then remove somewhere between 10 or 12 walls. And then we get the same kind of sparsity that the original had. Alright, let's get cracking. So all we really need to do is, well, first of all, let's see where, bingo, we have one method here called generate maze. It picks one of the mazes at random and then just calls one of these methods. I'm going to leave this alone for rule seed 1 so that the original maze is still the same. But for the rest, I'm going to write an algorithm. Okay, so let's see, generate maze. Okay, so here in start, before generate maze is called, I'm going to run the rule seed. Okay, so in order to do that, I first need the km rule seedable component. Let's put that here. And then var rule seedable equals rule seedable. No, actually, I just want the random number generator. There we go. And then we're going to output a log message saying what mouse in the maze, saying what mouse in the mouse. Alright, mouse in the maze. Let's see what capitalization the other log messages use. Yep, that is the same one. Okay, so for this mouse in the maze, module ID, we are using rule seed that, and that is rnd.seed. Okay, and now, if rnd.seed is not equal to 1, then we're going to generate a maze, or rather 6 mazes. Right, generate 6 random mazes, and then remove 10 to 12 walls from each. Okay, so for each maze, 0 to 6, we are going to have, let's see, we're going to have a horrors wall. What was the original? Right, horry walls. Okay, so I'm just going to call it h walls for this one. So the horizontal walls for this one are going to be a boolean of size, what was it, 10 and then 9, I believe? Yes, it is. And then the vertical walls are going to be another boolean array of the same size. Right, but we also need to keep track of which positions in the maze we've already visited. Okay, so we are going to have 3 structures here. One is going to be a to-do, which is going to contain everything at the start. So we're just going to fill that. Whoops, I meant enumerable. Okay. Apparently typing after badminton is a little bit hard. Okay, so I'm just going to turn that into a list. Okay. And then we're going to see which ones we've visited. That's going to be a list of integers. And then which ones are already done. That is also a list of integers. Okay, and then while to-do.count is greater than 0. Now let me think if that is actually the condition that we want. You may remember that I've explained this algorithm before using Inkscape, and maybe I should do that again. And so I'm just going to do that right now. So here's how the algorithm works that I'm about to write. Let me create a black line. Yeah, there you go. Black is a bit strong. Let's do that. Okay. So, I actually want, hang on. No. Right, I actually want 10 separate lines here because I'm going to need to be able to remove lines individually, right? So we're just going to create all of these lines. Okay, and then we're going to do the same for the horizontal walls, right? So that is going to be a wall, 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 and we're going to have 10 of these, and then we're going to have 10, or rather 11 rows of these. Okay, now I feel in hindsight that they are a bit thick, so let's do that. Okay, so the idea here is, let's actually also draw a rectangle on every square, which I'm going to make blue for now. All right, so let's have 10 of these. Okay, and then I'm just going to select all of those and copy them over down here. Okay, so here's how the algorithm works, right? We start by selecting any square at random and we make it green. That's the first thing we do. And then here we start a loop. So pick any green square. Oh, there's only one, right? We pick that one. Pick any of the walls adjacent to that square. Okay, let's pick this wall here. Right, let me actually 1 second. Let's select all of these and put them on the bottom, and let's also remove all of their strokes. Not their fills, right? Let's undo that. Remove all of their strokes. There we go. This is what I wanted. Okay, so now I can select this and remove the wall. Okay. And then the square that we went to with that wall, we're gonna make that green. Okay, and then again, pick any green square. Right, let's pick this one again. Pick any wall next to that square. Okay, we pick this wall here, so we remove that wall, make that green. Now pick any green square. Okay, let's pick this one. Pick any wall. Okay, let's pick this one, make that green. Pick any green square. Let's pick this one again. Let's say we pick this wall. And for the sake of this example, let's say we pick this square once again. Pick any wall. Well, it has only one, so we have to go here. And the next time, alright, so so now this one might go here, whatever, this one might go here, and then sometime later the algorithm might choose this square again. And now it will say, wait, we can't pick a random wall because there aren't any. We've removed all of the walls around that square. So what we do at that point is we make this yellow. Or we just make it some other color. Okay, and this is done. Okay, so this square will no longer be chosen because every time we start the loop, we say pick a green square. So marking it yellow just takes it out of consideration. So every time that a square, so let's take out this wall here and make that one here green. Okay, now here is another restriction because it might choose this green square and then say, oh, there is a wall around it, this one. Right, but we don't actually want to remove this because that would create a loop. How do we know that it would create a loop? Because the square on the other side is already green. So what we're actually looking for when we choose a random wall is we want to choose a wall that takes us to a blue square. So this wall here that is between two green squares is also out of consideration. We always choose a wall that goes to a blue square. Okay. That is how that algorithm works. If you guys have any questions about how this algorithm works, please feel free to ask them. Tunwi does not enjoy the code. I enjoy the code a lot. I have no idea what you're talking about. So we're going to implement this algorithm as I suggested it. So we're going to start by picking a random blue square, which is in to do. So we're going to call that the starting square. And that's going to be a random, so we have to use the random number generator from the rule seedable component. So we're going to pick a number from 0 to 100, and we're going to add it to the visited squares. That makes it green, and we're going to remove it from to do, because it's no longer blue. Okay, and now for as long as there are still blue squares, right, because once every square is green, then we know that every square is reachable because we've removed a wall that takes us to it. So once everything is green, we're basically done. right? And then at the end, we can just add all of the remaining visited squares to the done array. Well, in fact, we don't even need to do that, because obviously that would just give us the list from 0 to 99. And, what we actually want to end up with is the walls, and we have those right here. Which reminds me, as you may have noticed, what we actually do every time, every step, is we remove a wall, which means that we actually start with all of the walls set. So I'm actually going to go for I equals 0 to 10, and for j equals 0 to 9, I'm going to set both h walls of ij to true and v walls of ij to true. And then we're going to successively set them back to false as we create the maze. Alright, so pick a random square. Pick a random square from visited. A random square that we can already reach from the starting square. Random square equals, I'm going to generate a random index from the visited list first. So this is going to be rnd next 0 visited dot count, right? Yeah, and then we want to remove that from visited. So we remove at that index, so the random square index. But actually, before we remove it, we want to find out what the valid walls around it are. So we need to find which of the squares around it are still blue. All right. So var valid neighbors equals list of int. Now, if we are not on the left edge, then we have a left neighbor. So if the x-coordinate, now the x-coordinate would be, I should probably know what the square is. The square is, of course, visited at that index. There we go. Okay, so if that modulo 10, which is the x-coordinate, if that is not equal to 0, then we have a left neighbor, which we might want to add here, and that would be square minus 1. That is the left neighbor. But we need to make sure that this left neighbor is still blue. So we need to check if to-do contains the valid neighbors, the square minus 1 actually. Right. And now we do the same with the right edge, right? If we're not on the far right edge where the x-coordinate would be 9 and to-do contains square plus 1, then that is also a valid neighbor, so we add that. There we go. And then we do the same thing with the y-coordinates. Okay, so if we divide by 10, we get the y-coordinate. If we're not on the top and the top neighbor is still blue, then we can add that, and the same for the bottom. Okay, and now, of course, right, at this point, we can remove visit. Right, actually, we can already remove that here because we're only going to use the value of SQ rather than the index. Right, so the square that we go to, well, first of all, we need to pick one of these valid walls. And obviously, if there aren't any, right, okay, so we first need to check if there aren't any. So if there aren't any, then we want to make this square yellow, which we do by adding it to done, and, we've already removed it from visited. I'm starting to think that maybe we don't even need the done array, because all we really need is for it to not be in visited. You know what I'm saying? So I think we don't even need to add it to done. So I'm just going to say continue. So for now, I'm just going to comment out this line, or even just remove it entirely. And if it turns out later that I still need it, then I can still get it back. But we don't really need it, right? We need the h walls and the h walls and the v walls, and that's what we're going to end up with. Okay. So if valid neighbors.count is 0, then we continue, because now we've reached a square and removed a square that, wait. Yeah, we don't actually want to remove it from visited at all. We only want to remove it from visited if valid neighbors.count is equal to 0. Right? This is when we make it yellow. But if we just remove a wall, then we're not, it stays green. It should stay in the visited array. So yeah, so let's leave it in. Alright, so now that we know that there is a wall to choose from, we can decide on a random index for that. So decide on valid neighbors.count. There you go. And then the neighbor, which I'm just going to call nay, is of course the valid neighbors. Actually this should be the neighbor index really, is valid neighbors at that index. Okay, so now we need to figure out which wall is between the current square, SQ, and the neighbor that we've just decided. Well, if their x-coordinate is the same, then obviously we're going to be changing a horizontal wall. Right? If their x-coordinate is the same, then it means they're on top of each other. Right? So we'd be removing a wall like this one here, which is a horizontal wall. So we want to set h-wall of something to false. Right, but what is the something? Now the x-coordinate, obviously, because we know that to have the same x-coordinate, it's literally just that x-coordinate. But what is the y-coordinate? Well, the y-coordinate is going to depend on, okay, so the y-coordinate of this one here is 0, right? So if the square and the neighbor, if one of them is at 0 and the other one is at 1, then we want the 0. If one of them is at 1 and one of them is at 2, we want the one at 1. So that seems like the lower of the two. So I'm just going to say math.min of the y-coordinate of the square and the y-coordinate of the neighbor. And I believe that should be correct. Else, if the x-coordinate is not the same, then they must be horizontally adjacent, and we're looking to change a vertical wall. So now we're looking at the y-coordinate. Right? The y-coordinate is the same. And then the x-coordinate, remember that these two indexes are swapped this time, right? So the y-coordinate comes first. And then the x-coordinate, of course, once again, is going to be the lower of the two, right? If we have these here, where the x-coordinate is 0 and 1, we want the wall at index 0. So I'm just going to copy the exact same code here, except that this time we're dealing with the x-coordinate. And that should be it. And obviously the neighbor should now be a visited square, so we're going to add that to visited, and it is no longer blue, so we remove it from to-do. And that way, eventually, the to-do list will run out of things and the while loop ends. But, the funny thing is that we actually select from visited, but we always select a wall that takes us to something that's in to-do, and that is why every iteration of this will remove something from to-do. And so we will actually end up removing exactly 99 walls. No, not 99. Why aren't we removing 99 walls? Yeah, that's right. We are removing 99 walls, and there are 180 walls to begin with. So we are left, that's it, we are left with 81 of them. Is that what I had? Okay, I put 89, but that's wrong, right? 180 minus 90 is 90, and then minus 9. So we're actually left with 81 walls, and then we want to remove somewhere between 2 and 4 walls from them to create some loops in there. Okay, so now remove between 2 and 4 random walls to create some loops. Okay, now how do we decide which walls to remove? Right? There are two ways. We can either generate a list of all of the walls and then pick at random, or we can pick a random wall, see if it is a wall, and then just keep doing that until we've removed the number that we want. Now, ordinarily, I recommend the former, but in this case, these mazes are pretty much full of walls, and we are only removing very few of them. So I'm actually going to do the latter, and I think that that will also be computationally acceptable, because we won't need to create that entire list of walls to pick from. So I'm just going to decide on num walls to remove, and that is going to be somewhere between 2 and 4, which we have to put down as a 5 because the max value is exclusive. Alright, and then for I going from 0 to num walls to remove, Um, no, actually, wait. I'm going to do this while the number of walls to remove is greater than 0, right? This way I can decrement it only when I actually remove a wall. So let's see. Var h, so decide whether we want to remove a horizontal or a vertical wall. That's just that. Um, and then decide on a, so instead of x and y, because the v array has the x and y swapped, I'm going to call them I and j, except that, yeah, I'm going to call this maze index so as to not have a clash. Right, so I'm going to call them I and j just like I did here. So the I coordinate is going to be between 0 and 10, or rather between 0 and 9, but you get the idea. And j goes from 0 to 8. And now, if, let's see, if we're looking for a horizontal wall, then let's check this one. So we want to remove the wall if it is a wall. So if that is a wall versus if that is a wall, then, right, only if this is the case, right, then if hv, then hwalls ij is equal to false. Else vwalls is false, and now we can decrement this. And then hopefully that will finish within reasonable amounts of processor cycles. Okay, so now we've created 6 mazes contained in these arrays, and now we need to save those somewhere. So I'm just going to create a list of them, right? We have a list of, actually I'm just going to do 2 lists, one for the horizontal walls, and this is going to be a list of Boolean 2D arrays, and then one for the vertical walls. And then here at the end of this loop, I'm going to say generated hwalls.add hwalls and generated vwalls.add vwalls. And now we will have 2 lists, each with 6 elements in them, and we can just use the right one. So here I'm going to say, so here is the end of rule seed code. And then here in generate maze, I'm going to pass this in, generated vwalls. Yes, I can type. I'm going to pass that in, and obviously if the rule seed is equal to 1, then this will be false and none of this will be done, and then the list will just be empty. Okay, and it will just not use the lists. Alright, let's add these parameters. And you may have noticed that we've just added these parameters here. So I'm going to rename this to hwalls, this to vwalls. And here I'm going to say if, oh, right, we also want, okay, we can actually just use this. If hwalls.count is greater than 1, is greater than 0, right, then we have rule-seeded mazes. Else, we do this. There you go. Default rule seed. Or regional mazes. Let's do that. Okay, so if that is the case, then hori walls is just going to be hwalls of that, and vert walls is just going to be vwalls of the same. And then that should do it. That should generate the maze. Okay. So shall we try that out immediately? Because obviously, I don't know what the mazes look like. But you know what? Let's just try this. So first of all, of course, I'm going to have to add the km rule seedable component here. Okay. Okay. So it's saying missing because we renamed the script. So I'm just quickly going to drag that back in. And I'm glad that all of these associations are still there. And of course, rule seedable is now going to be this. And you know what? It's called physics module. I'm still going to call that mouse in the maze. There we go. Right, and the module type has always been mouse in the maze, so that doesn't even bother anyone. Okay, so now if I run this, it should now generate the standard mazes, as in the ones that we know and love. And by generate I mean use, right? It should just use the mazes that are hard-coded into the code. And there we go, we have one with a blue torus on the corner. So this is on a corner, this is on a corner, and this is on a corner. But that corner is right next to a four-way junction. And this is clearly not a four-way junction, and this is not a four-way junction. So this is where we are. And we just came from a dead end, so I'm guessing that that's this one, and we're here. No, if we were here looking up, then the torus would be on the right. We probably went here. Well, anyway, the torus is on the left, and clearly the four-way junction, I mean, we're clearly looking west. So we have a blue torus, we're looking for the yellow sphere. Yeah, I think at this point we can be fairly satisfied that this is indeed the maze that is in the manual, right? So now I'm walking past the green sphere, and I'm gonna be finding the yellow sphere somewhere here. So this is where I need to turn right. And then at the end of this corridor, or rather in the middle of this corridor, we have the yellow sphere, and that's it solved. Okay, so now let's go to rule seed 2 and see if anything unusual happens. Well, as best as I can tell, that is totally a fine maze. It's definitely not one of the mazes that, that we know and love, but we want variety, we get a new maze, and this actually looks really unusual. Here's the white sphere, and right. So now that we've generated the maze, which obviously consists of these walls, there is actually one other important thing that we need to do. We also need to decide on the stuff that's over here. And also which of the spheres has which color. As you can see, they're not always in the same arrangement. That needs to be part of the rule-seeded rules. So I'm going to take a look at how these are encoded. So here, when we generate maze 1, we don't just set the walls, we also have these sphere colors, which are clearly numbers 0, 0, 1, 2, 3 in some order. The torus color, that should not be part of generate maze, should it? But it decides on the goal position here. Okay, I'm quickly going to change this. Right? What I want is I want every maze to have a mapping from torus color to sphere color. Right? So for each torus color, we want a valid sphere color. Well, it says goal position. And we've already figured out that the goal position is actually the position of the yeah, that's right. So goal position 0 is the bottom left sphere. Goal position 1 is the bottom right sphere. Goal position 2 is the top right, and this is the top left. So they're going counterclockwise from the bottom left for some reason, but right, okay. So, right, let's go back to generate maze 1. Here we go. So we've set all of these walls, and we're setting the sphere colors. But we don't want to decide on the torus color here. Instead, we want an array, right? I'm going to put that array up here, and this is going to be an array that takes us from torus color to goal position. So goal from torus color. And that's going to be an array, like this. Okay, so this array is going to have 4 entries, right? So goal from torus is going to be a 4-entry array. Okay, and let's just write it out like this, right? So if the torus color is 0, then the goal position is 0. Otherwise, it is 1, 3, and 2 in that order, right? So this is what we should put in each of these generate maze things. But we need to put this code outside of it. In fact, we need to put it outside of the rule-seeded code as well. So here, where it says generate maze, after we've done this, we are going to decide on a torus color, and then the goal position is of course goal position from goal from torus of the torus color. Come on, torus color. Why does it change that? It's interesting. Alright, anyway, torus color. So we don't need that anymore. And we can report the torus color and the goal sphere color, of course, is not the goal position. I see. Okay, so sphere colors is another array that we need to populate. So where is sphere colors populated? Right here, of course. Okay. So the rule-seeded... okay. So this is going to be interesting, because the rule-seeded code on one side, on the C# side, is going to generate which goal position, which torus color decides which goal position, but the manual needs to decide which torus color decides which sphere color. So that's going to be interesting, because we're going to be using this array to map between the two. But anyway, let's finish this here first. We don't want this, we want this. Goal from torus color is going to be 0, 1, 3, 2. Oh, that is the same array. Interesting. Let's see if they all have the same array. 0, 2, 1, 3, right? It's not the same one here. 0, 2, 1, 3, 0, 2, 1, 3. Interesting. Okay, this one here. Ooh. No idea why that's there. 1, 2, 0, 3. 1, 2, 0, 3. Okay, let's remove extraneous lines here. Extraneous empty lines. Here we want 2, 1, 3, 0, 2, 1, 3, 0. Okay, and then in the last one we want 0, 1, 3, 2. There we go. Okay. Now let me make absolutely sure that that still works for the standard rule seed. Right. This will now crash because that array that I've told it to use has not been initialized. Alright, so it says goal sphere color is yellow. So let's quickly find the yellow sphere. See if I can find. I'm going to zoom in a bit. Aha, we have a yellow torus on a wall, on a straight wall. So it's either one of these, but it has a right corner. Can I, if I go back? Aha, I can go left. So I'm probably here looking down, because the torus is on the right. Yes, so I think I'm here looking down. So going to the yellow sphere means going here and then left. Yep, and this seems to be the right maze. Okay, that seems to work. So I'm pretty confident that these goal from torus color numbers are correct, at least for the one maze that we just tried. But you know, you guys will tell me if I got them wrong, right? If you observed any of these. For rule seed support, does the manual and the module use a similar algorithm for the different mazes? Well, obviously they have to use exactly the same algorithm. You know, they have to be absolutely precisely identical. Otherwise, the module would be following different rules than the manual, and we can't do that. So what am I looking for? I'm looking for notifications here. I want to turn that on, enabled, so that I can see when you guys say something in the chat. Okay. Go ahead and say something now to check if that notification is working. Alright, so now that we have that array, we are going to go to the rule-seeded code, which is, I called it start. Start, no. End of rule-seeded code, there you go. Start of rule-seeded code. Alright, I saw that notification there. Let's move that there. Hello, yep, thank you. That seems to be working. Okay. So if the rule seed is not equal to 1, then we generate 6 random mazes. And for each of those mazes, right, we need to... right, so we're still going to have another list, which is generated goal from... You know, I'm going to call it sphere from torus this time, and this is going to be a list of integer arrays. Each integer array is going to be 4 numbers. So the reason I'm doing this is to make it easier for me in the manual, right? It is easier to go from the sphere to the position because the sphere to position thing is already here. Um, oh, maybe not. Actually, this allows me to go from position to sphere. Right, but anyway, I want to make it easier for myself in the manual, so I'm still going to go with this. So what I will need to do then is, so first of all, generated sphere from torus. We just add the numbers from 0 to 4 in a shuffled way. So we're going to use the rnd.shuffle to shuffle that. And then, of course, we actually want that as an array. Okay, so that will give me the sphere from the torus position, and then to get the goal position from the sphere, I need to know where the spheres are, right? So I also need to generate sphere positions, right? Generated sphere positions. These are also going to be, there you go. These are also going to be in a random order, 0, 1, 2, 3, 4. So once we have this here, this will decide on the torus color, but this doesn't know what to do with, what do you mean rip? I'm not quite sure what you're talking about. Okay, so generate, so I'm just gonna call this goal from, what was it? Goal from, no, it was sphere from torus. I can't remember what I called it. Yeah, sphere from torus and sphere positions. Okay, list of int sphere positions. Okay, so if we are in the standard rulesy, then obviously these generate maze things will already do that. But here we want to set goal from torus color. Ah, of course, this just uses goal from torus color. Yeah, you know what? I'm gonna do this. Goal from torus. Let's just do that. Go from torus of the maze that we've decided, and then here it will use that to decide. Yeah, so we actually need to pass in the correct thing. So I'm going to call this goal from torus, and I guess what that means is I'm actually going to have a harder time in the manual, but it's not going to be a big deal. Okay, so generated goal from torus and generated sphere positions. There we go. Ah, but sphere positions is not actually being used, right? Because sphere colors. Ah, that's it. That's it. We need to set sphere colors. It really, wait, sphere colors, why is it called sphere colors? Is that because it's, right, clockwise order from top left. So this actually goes from position to sphere color rather than from sphere color to position. Oh my gosh. Okay, so I'm gonna call this sphere colors. Right, and then sphere colors is equal to sphere colors of the generated maze. And then here we're going to call this generated sphere colors. Okay, so this is actually going to be even more confusing for the manual. So what we end up having is we have the sphere colors in clockwise order, and we know which one of them to go to for each torus color. And then, of course, so right, the two cancel out and it's easy again. So for each torus color, I'll just look up the goal position and then look up the sphere color from there, and then I can just, yeah, alright, so it's actually much easier. Okay, so, good thing I can plan ahead. Alright. Now, I'm a bit irritated by the fact that this is so spaced out and so bulky, so I'm actually going to just do this, just to have it more compact. There we go. Slightly more readable that way. And with that, I think we're off and running. So I think if I run this under a rule seed now, which once again I forgot to set, it should no longer crash like it did last time. So let's do a rule seed 12, why not? And indeed it doesn't crash. Okay, now obviously I don't know what the maze looks like, but we're looking for the green sphere somewhere. Okay, let's just walk the maze a little, and if we happen upon the green sphere, which I did, and that worked, so it showed the correct sphere color in the maze and in the logging, so those two matched up. The torus color is also matching up, but that's not much of a surprise here. Ooh, the blue color sphere. Let's take a look at that. And that seems to work. Now I also need to make sure that a wrong goal sphere color actually gives me a strike. So I think I want to test that. So I'm quickly going to turn off the Twitch place thing so that I can actually see from the red light that I got a strike. I suppose I can also tell from the number above the timer, but okay, so here's a green sphere and the goal is blue, so that should give me a strike. And it did, because you press submit on 2-2, but the solution is 7-7. Okay, cool. Alright, that seems to be working. So now, all that we need to do now is to transfer this algorithm, to the manual. Yeah, let's set the rule seed back to 1 for now, I guess. Just to save the file, I guess. Okay, and now we're going to take a look at the manual. Okay. I'm going to keep this open for, not this, I don't need this. I'm going to keep this open so that I can check the number of walls later. Alright, let's open Mouse in the Maze. Right, there are 2 translations which I may need to copy the rule seeded code into. So we're going to add the rule seed.js here, and we're going to add a script tag. Alright, you know what? I just realized, why don't I write this code in Visual Studio as well? Nice color scheme and ooh, border bottom length. That is not a CSS project. I don't know why that is there. Also, apparently the /html tag is missing, and the indentation was wrong, and we fixed all of that with one fell swoop. Okay, so there is a /p missing. Not that that matters much, because /p is actually optional, but whatever. Okay, so we want to, okay, so first thing I'm going to do is, we already have these class declarations on them, so we're going to use those to identify the TDs that we need to put the mazes in. But obviously we also need these here, so I'm going to change, let's see. Okay, so every occurrence of TD followed by a single word, followed by TD, followed by another word, followed by /tr, should be replaced with class equals torus, that, /td, td, class equals sphere, that, /td, /tr. Okay. Okay, now I've added the missing /tr tags there, but I'm betting that this one, yeah, these are also missing the /tds. I can't really be bothered to fix all of that. I wish there was a button to just add all the missing closing tags. That would be very useful. You know, maybe there is one. Visual Studio HTML add missing closing tags. Let's see if there is a shortcut for that. Highlight matching tags. Let's see what that says. Find unclosed tags. Yeah, that's not Visual Studio anymore. Let's see. Use the official HTML validator. Yeah, okay. That's still not HTML. Still not Visual Studio. Okay, so I'm just not gonna care. All right, script. So I'm going to copy all of this code, this entire for loop, and right. So the first thing we need to do is to declare a function for the function. Why did the cursor move down there? It's so strange. Function set rules, and of course function set default rules, which doesn't need the RND because that one's going to be hard-coded. Now I'm quickly going to plonk that in here and comment that out, because we're going to translate that to JavaScript. But before we do that, and that needs a close curly, I'm going to decide on, right, how about this? Function set mazes. Okay, so we're going to have a function that will take all of the mazes as an array, and it will also take all the other info, like each of these. Right, actually, let's do this. We have horizontal walls, we have vertical walls, we have goal from torus, and we have sphere colors, like that. Okay, and each of these are arrays with 6 elements in them for each of the 4 mazes. So here we're going to have that. Okay, but I'm going to do that later. First, let's fill in the default rules. So right, I probably want to because we have these wall arrays that are all 10 by 9, and they're all either filled with falses for rule seed 1 or trues for rule seed for every other rule seed. Hello, Red Penguin, welcome to the stream. Okay, so I'm just going to default value. Let's do that. Okay, so I want to generate an array inside of an array. So let's also, I need to get into the habit of using let in JavaScript. So we're going to generate an array, and then for this is where the var came from. Okay, so we want to create so that the first index was 10. Yeah, the first index is 10 elements, so we do that, right? And then we create an inner array, and then for I should have put in the j, right? So now we want 9 values, and then we just put the default value in there, and then we push that array into that, and then we return that. Okay, so that's just a helper function to generate one of these arrays and to fill it with either trues or falses, right? And in the default rules, I'm going to start by filling it with falses, and then put in the trues that we already have right here, right? So each of these, I'm just going to copy all of this like that. What was that? Do you think JavaScript bad? I think JavaScript is lacking. I think C# is better. But, it's not the worst in the world. I mean, there are definitely worse things than JavaScript. But it is a bit unfortunate that we're stuck with JavaScript in browsers. I don't really understand why that is. I don't understand why they didn't implement something that you can compile to. Something like IL or Java VM or something. I think Pascal is better than JavaScript, to be honest. Much, much better, in fact. I don't know what Janine is, but I'm guessing it's a dialect of Pascal. Yeah, that is indeed a... wait a second. No, that is a name. That is a person. You don't know Janine Pascal. Yeah, well, I do now. There's her photo. That is Janine Pascal, or some person named Janine Pascal. Anyway, so here's the thing. This array, or rather this information, is of course pretty lengthy, right? So I think I want to compactify this. It's the Pascal scripting language from the Lotus simulator. Okay, so it is a dialect of Pascal. That makes sense. Now I'm going to compactify this in the following way. I'm going to make a single string that contains only these numbers. Alright, so what do you mean wait for regular expression support? You can write a regular expression engine in any language. You don't need the author of the language to do that for you. So let's do the following. So first of all, I'm going to change. Okay, what's the most effective? The most effective way of doing this is to output the mazes in in Unity. So that's what I'm going to do. Yeah, so I'm just let's go to the start method and write some temporary code, like generate maze 1. Okay, so when we call that, then hori walls and vert walls will all be set. Sphere colors will all be set, and go from torus. Yeah. You know, it just occurred to me that sphere colors could also be written as an array. You know, like I could say sphere colors equals like this, and then 1, 2, 3, 0. I think I'm going to do that. That's just a little more compact, and it'll be easier to just copy that into JavaScript then. Well, not easier, just more compact. Let's see, 3102. Let's do that. And then here we want 0312. And then the fifth one we have 3021. 3021, 3021, there you go. And then finally we have 2301, there you go. Okay. Now, where was I? I was in start, and I'm gonna say generate maze 1 and then debug.log, log format, whatever. Yeah. So what I want to do is I want to output, you know, I'm just going to make it a long string of zeros and ones. Yeah, let's do that. So the horizontal walls are just going to be enumerable.range from 0 to 10, I believe. The first. Where do I want to do? Yeah, I think I want to do the outer loop. I want that. Okay, so that's the J, and then for enumerable range 0 to 10, I, and then if the horizontal wall at that index ij is true, I want a 1, else a 0, and then I want to join string all of that, and then join string all of that. Right. That's the horizontal walls, and that's the vertical walls, and obviously this will break the module, right? Because now we're calling generate maze twice, but that's okay. I only need the log message at the start, this one here, and right. Let's go to the JavaScript here, right? And maze 1 is going to be, well, the horizontal walls are that, and the vertical walls are that. Okay. In fact, I'm going to do this. Okay. There we go. So that's our first maze, comma, right? And now the horizontal walls for the second maze are going to be generate maze 2, obviously. You guys said something. Ooh, I didn't mean to run Discord. Yeah, I see. I see your problem. This, what you say about copy paste, that reminds me of C and C++, which does something very similar. And I'm actually quite surprised that a language with that kind of feature became this widespread and popular as C and C++ did. But yeah, you are absolutely correct. Delphi is actually better designed. Like, it doesn't just copy and paste stuff. Anyway, we're not here to talk about that, so let's get on with this. So horizontal. Okay, so I wanted to go here, so that's the horizontal walls for maze 2, and the vertical ones are these. And you know what? I think I'm going to improve this by saying open curly bracket h colon double quotes that, comma v colon double quote that, and then close curly, right? That way I can literally just copy and paste it. And let's put both of those in there, like that. Okay. So I guess I'm going to put this on a line. I'm going to put this on a line, put a comma after it, right? And now we generate the others. So generate maze 3, please. And now I can literally just copy and paste all of this. Bang, and it goes right here. There we go. Comma. And then we want maze 4, which unfortunately needs to keep recompiling, so it takes a bit of a moment there, but not too long. So there we go, let's put that there, we can delete that. Okay, that was maze 4, only 2 more to go. Maze 5. Maze 5 is this, and allow Unity to recompile this. There you go. There we go. And then just run it. And here is maze 6. Okay. So now that we have these mazes, I totally forgot that I have horizontal walls and vertical walls separately here. But you know what? I think that is actually not a big deal. Right. Because here's what I'm gonna do, right? In fact, I'm gonna change this back to mazes, and each maze is going to be is going to have each of these properties: the H, the V, like that, and then each of them is also going to have something called what was it? Goal spheres. Ah, here it is. Right, goal from torus, I guess, which is going to be an integer array, and sphere colors, which is going to be an integer array. So let's get them all. Generate maze 1 has these. I'm going to do this, right? Let's do this. Maze 2 has these, and then maze 3 has these. There must be a faster way of doing this, but there are only 6 mazes, so it's probably not worth writing extra code to extract all this. So there we go. Okay, so now let's replace all of this with that, and all of that with this, and all of the equal sign with colons, and all of the semicolons with commas. There we go. Alright, and then we can literally just plonk that in here. You know what, I'm actually going to put that on top so that I can easily I should probably not have had the empty lines in between. There you go. So now I'm just going to move that to here, that to here, that to here, that to here, and that's it, done. Okay. So that should be the default mazes, right? So now, instead of assigning that to a variable, I can literally just say set mazes, parentheses that. There you go. And that is an array of 6 mazes. And now I'm going to right. Let's now write this code here, which will generate the SVGs. Okay. So yeah, let's actually start by setting these here, the torus color and the sphere color, because that's the easiest part. And here's the thing: I want to show these in a random order because they are randomized here, even though the order doesn't matter. So I'm actually going to add. Yeah, how about that? I'm actually going to add yet another key to this called torus, like torus order or something, right? And this one I'm actually going to generate at random because in the module you don't need that. You know what I'm saying? In the module you don't need the order in which they are listed in the manual. So anyway, so here I'm going to say torus order is going to be, okay, so we want an array of numbers from 0 to 3, which is I think right, this is how I did this: array from array so we want 4 values and their keys, and that gives me an array, right? And then I want to use shuffle Fisher Yates of that. There we go. Okay. And then we put all of those in here. Okay, not quite sure why it's complaining about this. Ah, it's disappeared. Okay. So now we have a torus order, which is generated at random from the rule seed, but is the same every time. Okay, so now, so we have this for loop for the mazes. We're going to need all of the torus TDs, which is the table cells, right? So here, all of these with class equals torus. So we're gonna get them from the document.getElements by class name torus. Right, and then of course we want the sphere TDs similarly. Sphere. Right, so the torus TDs are the ones on the left, like this, like all of these here, and the sphere TDs are these on the right here. Right? Not this one, but you know, just these. Which means, okay, so we need 4 toruses, right? So for each torus, we also need to know what the colors are. These are the sphere colors. Do the torus colors match that? Let's see. White, green, blue, yellow, white, green, blue, yellow. Bingo. Yes, these are the correct torus colors. So let's go here and let torus colors be an array with those names in it. White, green, blue, and yellow. There you go. So we want the torus TD. Okay, so how many torus TDs are there in each maze? 4, of course, right? So it's 4 times the maze plus the torus we're looking at, and we want the inner text for that to be equal to the torus colors, which should really be called torus color names. I'm okay with this. Of now we need mazes of maze.torus order, that one. So that will give me the right torus, and then, yeah, okay, I think this is correct. Right, and then for the sphere TDs, let's see. So the correct color at this point, right? So we need to. So we have the colors. I'm just gonna put that in a separate variable. So this is the. Oh, excuse me. I wanted to put this in a separate variable. Okay. So this is the color of the torus, represented as a number, and I need to get the goal position from that. Right, so the goal position is going to be goal from torus color, and now that we have the goal position, we're going to get the color of the sphere from that. So the sphere color is going to be, you know what, instead of torus colors, this should really be called colors. So I'm going to take this opportunity and rename it to color names. So we want the color name of the sphere color of G. Right, so sphere colors of G. That. Okay, so now if I run this locally, right here, mouse in the maze, I should be getting the same information here, but in a different order as I do here. Now it turns out they're identical, but that probably means there was an error. But there's no error in the... did they change now? Yeah, it still didn't change. Of course, it could be a huge coincidence that it generated the same order, but I find that very unlikely. So let's output a log message here just to see if, yep, that code does actually run. Well, in that case, then let's just go to a different rule seed. Yeah, and it still hasn't changed them, so that is clearly not working. So let's figure out why that is not working. Why does it say length here? That should be 4. There are 4 toruses. Okay. Okay, now that looks a bit more like it does something, but it's obviously not what we want. Um, okay, so the mazes. Okay, so let's take a look at Taurus order of Taurus, obviously. Yeah, that should be it. Okay, so blue goes to white, and indeed blue goes to white. Yellow goes to yellow, and indeed yellow goes to yellow. Blue goes to white, and indeed, oh yeah, I've already done that. White goes to green, and green goes to blue. So it seems that the association is still the same, it's just in a different order. Right, and then here we have green, blue, white, yellow. So green is blue, green is, ooh, this one does not match. That is worrying. Alright, let's take a look at this one. White goes to yellow. That one also doesn't match. Okay. Oh, of course. No, not of course. See, for a moment there I thought it's because it does them in columns rather than in reading order. But why would it? Of course it's in reading order. Okay, I have an idea. I have a suspicion rather. Because there are these, bingo here. So the mazes are actually, that's it. So the mazes 1, 2, 3, 4, 5, 6 are actually in this unhelpful order. So I could rename them. Yeah, you know what? I think I'm going to rename them. And then change. Yeah, let's do that. Okay, right. So instead of 1, 2, 3, 4, 5, 6, which are going in this order, 1, 2, 3, 4, 5, 6, we now want them to go in this order. So 1 stays 1, and then what used to be the second one is now 3, and what used to be the third one is now 5, and then we go 2, 4, 6. Okay, so now we've changed them. We now need to go back to this place here and change the order of this. So we call this one the top right, then we have middle left, and then middle right, and then bottom left, bottom right. I think that is all that we need, right? That should literally be the only thing, right? Because apart from that, yeah, I think, yeah, it'll just select one at random right here, and it'll select them according to the new ordering. So all I need to make sure is I just call it the right thing from the manual. But I also need to make sure. No, but these are all generated by these, so they're all correct. And I don't care about these ones here because, you know, they're randomized. As long as the manual generates the exact same ones, it is fine. So I think that's literally all we needed to renumber the mazes. So that's pretty cool. Excuse me. So now all we need to do is reorder them here. Right, so 1, so this is the old 1, this is the old 2, this is the old 3, this is the old 4, this is the old 5, and this is the old 6. And as we know, 1, 2, 3 now became 1, 3, and 5, and these became 2, 4, and 6. And now I'm going to reorder them. Right, so the 2, right, let's put the 4 here, and put the 2 here. 1, 2, 3, 4, 5, 6. Alright, and now we can remove these again. Come on, let's do this. There we go. Remove these. Thank you, that's what I wanted. Excuse me. So now if I refresh this, let's see if it holds up now. So this one here, white goes to green, white goes to green. Blue goes to yellow, blue goes to yellow. Green goes to blue, green goes to blue, and yellow stays yellow goes to white. Okay, so that seems correct. Now let's also check this one here, which has also changed. White goes to yellow, indeed. Green goes to white, indeed. And then yellow, blue, and blue, green. Yellow, blue, and blue, green. Okay, I'm happy with this. I think that all of the torus to sphere associations are correct. I mean, the order has changed, but who cares? It's still the same information. So we'll keep it like this. And now we're going to, you know, now that I think about it, why don't I Nah, whatever. I don't care. Okay, so now I want to actually generate the maze SVG. So now comes the actual interesting part. Well, apart from the maze generation algorithm, which we've already done, but the 3D maze manual, which I've created on a live stream some other time, already has the code to generate the SVG, which is right here, and it uses a lot of other code, which I'm going to have to copy around. So I'm going to copy this entire function here, create 2D maze SVG, and I'm going to have to change things around a bit, because instead of north walls and west walls, we now have these. I guess north walls is the same as horizontal walls, except it's south walls actually. But the other one, the west walls, has the x and the y coordinates swapped, so we're gonna have to work with that. Okay, so I think I'm just going to copy and paste all of this code all the way up to here and put it right here at the end of this thing. Okay, right. So this should all be the same except for this. Okay, so now instead of n walls, which is horizontal walls, I'm going to call this h walls and then look for all uses of n walls. Surely the sizes are 10 by 10, right? The size is definitely 10 by 10. I don't know why this would be, like in 3D Maze it's always 6 by 6, so maybe I should literally just put 6s here. But the algorithm is apparently capable of... okay, so here we need a function that tells me whether north of that coordinate we have a wall. And frame. It's cool that I didn't remove that, because in 3D Maze you do have a frame. So you don't have a frame. You have a maze that can wrap around, and that is why I put a false here. And now I can literally just change that to a true, and I will have something that draws a frame around it. Okay, so if there is a frame and the y coordinate is 0, which means we're at the top, then yes, we do want a wall there. Else, we want to check the horizontal walls, but this time, why does it say that? Okay, so the y coordinate is... Okay, I'm not quite sure why we're adding this amount. But what we actually want here is literally just y, except that if y is 0, then the answer is always true. I'm still really confused by the fact that it says that. I think I remember. This has something to do with this algorithm that I don't want to go into details on this, but I do need this modulo, I'm pretty sure. So what that is why it adds that, so that if y is negative, okay, that's what's going on. So right, okay. Okay, so that actually makes things a lot easier. But still, we actually want to subtract 1 here. And the reason for that is because let's go back to Inkscape. Right, in 3D Maze, we're looking at the north wall of each of these squares, and obviously the north wall of this one here, I mean, the y-coordinate here is 1, and the y-coordinate here is 0. So when the y-coordinate is 0, right, then in 3D Maze, because it wraps around, we do actually need to know whether there is a wall here, right? There could be no wall here. Right, but in Mouse in the Maze, there is never a wall there, so the array actually starts here. Which means that when our y-coordinate is 1, we want to look at the wall with the y-coordinate 0. And that is why I'm going to put a -1. Now, obviously, so the thing is, y could actually be negative, but it could only be -1, I think, for the algorithm. And therefore, adding another -1 is fine, as long as, we add the 10, we're in the positive, so it's fine. Okay, so that should be fine, and then of course the x-coordinate doesn't change. Now in the case of the west wall, let's see, if we are on the left, and we need a frame, then the answer is yes. There is a wall to the west of the westmost square, right? But for everything else, we now need to swap these two, and we need to be careful. So this is, oh, wait. Okay, I need to make sure that the arrays are, I actually put them as strings rather than arrays. Okay, so this is actually a string of zeros and ones. So I'm gonna have to take care of this. But first, I want to make sure that I get the, I want to pretend that it's the array for now, and then do the thing that I need to do to access the string afterwards. Okay, so that means that, okay, so the walls, are the walls always, no, they're not in reading order, are they? No, of course not. The horizontal walls are in reading order, because they just are, because it's x coordinate first and then y coordinate. So it's not actually in reading order. Gosh, I really need to make sure that I'm clear on this. Oh my word, I just noticed that the h walls and the h walls and the v walls are always identical. That means that I've made a mistake in my extraction of the code. Now I didn't delete the code here, so let's go back to start and look at it. And indeed, I put that is annoying. So here's what I'm going to do now. I'm going to yeah, and you know what? I'm just going to regenerate these, and this time I only need the v. So this part. I'm really sorry about that. That's a bit of a waste of time now, but I have to do this. I have to get the correct vertical walls. Okay, so this is the one for maze 1. So let's go here and fix that. Did any of you even notice that? None of you noticed that they're all identical. Okay, generate maze 2. Let's recompile that and run that. And copy that into here. Okay, and then we want maze 3. Yep. That would be this. Right, let's do maze 4. Maze 3 goes here. Okay, run this, get the numbers for maze 4, and change this to maze 5. There we go. And then run maze 5. Change this to 6. Put the 5 in. And then run the 6. And there it is. Okay. Now I sincerely hope that this is correct, but we'll find out, I guess. So let's go back to the JavaScript code now. Okay, so in the C# array, right, we have the first element is the x coordinate, like for the horizontal walls. The first one is the x coordinate. So I'm actually going to swap this because I'm going to have to change things around afterwards anyway. So I'm going to swap these back. I should have swapped only the top ones. And for the vertical walls, for the west walls rather, we want to look at the vertical walls. So let me think. In fact, let's go here. So now if the x coordinate is 0, right, we've already taken care of that, then we want the frame. If the x coordinate is 1, then we want the second entry here to be 0. So we actually need to -1 that one. Oops. Okay, that's fine. Right, and for the y coordinate, right, if the y coordinate is 0, then we want the 1 at 0 here. I think this is correct. Okay, So now we need to so in order to get the correct index in the string, first of all I'm going to use substring, right? Okay, so we have this coordinate. Ah, right, it's literally just plus 10 times the other coordinate, right? Because every row has 10 elements, right? We have 1, 2, 3, etc., 10 walls in one row, and then the next row starts 10 elements later. So I think this is correct. And then if that substring is equal to 1, right, then it is a wall. All right, let's try the same here. Substring of this plus 10 times all of this equals 1. Whew, I'm really not sure right now if this is even correct. It seems that this is cell function is unused. Yeah, indeed, it is completely unused. That's a bit surprising, but I'll just remove it then. Alright, now if I refresh this page, I'm pretty sure a lot of things go wrong. No, of course they don't. Ooh. Ah, this should be called V-walls. Vertical walls. No, of course things don't go wrong because I'm not actually generating the maze. I'm not calling this function. So for each of the 6 mazes, right, we've set the torus and sphere things. Now let's create ourselves a 2D maze SVG. And we want the horizontal walls, which is literally just that. We want the vertical walls. Labels. I think that is just a true or false. It just gives you labels on the rows and columns, right? So I think I just want that as false. Frame, of course, is a true. Omit axes, I'm gonna call true on that. I'm not quite sure how that differs from labels. Is labels even used? The labels. You see this for 3D maze, the labels, that these are the floor markings for 3D maze. So I guess for mouse in the maze, we do want to use that because we want the colors of the toruses represented by letters G, B, W, and Y. So I do actually want some labels there, so that is not false. Right, but omit axes should definitely be true, right? Let's see where that is used. Yeah. Okay, I should probably remove that entirely afterwards. And then extra is probably just an empty string. Let's see what the extra is. Right, it's just that. Okay, so let's just see what happens if I do this. Of course, nothing happens because it generates the maze, but then doesn't do anything with it. Let me very quickly take a look at how I use that function in 3D maze. And yeah, that's it. I just use inner HTML. There is a div around it, but that's because in 3D maze you have a caption at the top which says like ABH or BCD. We don't have that, so we're literally just gonna plonk that right into the relevant table cell. So we need the maze TDs, get element by class name, and I think they were called N maze or M maze. It's M maze because mouse maze, right? You don't want to call it maze because the vanilla maze manual uses that CSS to put CSS rules on objects. So I called it M maze. So now maze TDs of that maze.inner HTML is equal to that. Now let's see what happens. Okay, do we get an error? We get a lot of the label is undefined. Okay, so for now I'm going to pass in null, and then that will just not generate any labels. And now we have a bug. Okay, so this is not actually generating what I hoped it would generate. Okay, let me just very quickly take a look at this should be the same for 3D maze, and it should be the same for both, so that shouldn't matter. Get X grid get X 25. Why is there a 25? 5. Oh, I see. It's because the walls are 5 pixels thick in the SVG. That should be fine. Okay. Well, it did generate an SVG, right? It didn't generate nothing, but it generated something that has walls everywhere, which means that I must have made a mistake here, or I'm passing in the wrong thing. So let's actually see what I'm passing in. Right here, let's log in the console the H and the V. That's the H and that's the V. And I think I'm going to put something in front so that I'll know which is which. Like that. Alright, now we run this and we should get 6 different versions of that, and we do. And they're all zeros and ones. So that should be fine. Okay. So x size is 10, which means that this is always in the range 0 to 9. Right, and the same is true of this. Ah, but wait, we want... Ah, yeah, no, okay, I was gonna say we want this to be in the range... We want that to be in the range 0 to 8, but it is going to be in that range because of the -1. I think. Yeah, I think that should be fine, right? So if y is equal to 9, for example, right, then this will subtract 1, so it'll be 8. But if y is 10, then this one here will be true. So it'll never get to that. This should be fine then. So why is it not working? Okay, so I'm trying to figure out a way to debug this. I mean, the SVG generation thing seems to work. It just seems to think that there is always a wall everywhere. And why would it think that? I'm trying really hard here to figure this out. Okay, so how about this? I'm going to check. Right, so I'm going to output what this function generates, right? If x is equal to x and y is equal to y. See what the result is, right? N of xy is equal to result, right? So the result, let result is this. Return the result. And now I'm going to get a huge flurry of messages. Ah, interesting. Oh, the equals 1 is on the wrong side of that parenthesis. See, the C# compiler would have caught that, but the JavaScript compiler didn't. Okay, it's still wrong, obviously. Apparently I'm getting false for literally everything except the frame. That is awesome. Ooh, not everything. So there's one thing that was... Okay, so I guess what I'm going to output now is not so much the result, but rather the index, which is, you know, what I'm... Oh, substring... Ah, we actually want just one character at that substring. Right, that should work. There we go. Okay. Now, these are not the mazes that I expected. Right? The, ooh, I see. Oh, they are actually rotations of the maze that we expected. Yep. This one is... I see. They're upside down. All of these mazes are upside down. Okay. Okay. They're all upside down. Right, that should be easy to fix, right? Because we can literally just change the y coordinate. So that's interesting because that means that the array in the source code in the C# here is actually bottom to top. But it's not a big deal, right? All we need to do is I guess I can get rid of this again. Let's restore what it said here. It said this. So now what I need to do is I need to change y to y size -1 minus y. Can I please select? I want to select this parentheses. Thank you. So that becomes that. Okay, this should work. Did it work? Sorry, this is what I need to reload. It did not work. That completely messed up the end. Oh, of course. No. See, for a moment there I thought I only did it for one of the two, but no, I didn't. It's I did it both here and here. So why would that not work? That is very strange. Let me restore what it had, like this, right? These are definitely. Hello, lots of S. Welcome to the stream. Okay, so this is definitely the upside down version of. Right, I'm just checking each detail here, but it seems pretty clear to me. This is actually upside down, right? So if I just swap the y coordinate here, shouldn't that just work? Okay, so let me try this again. Y size -1 minus y. So I'm just going to try this again. And yes, I know I had parentheses around it last time. I don't think I need those parentheses though. So this gives me the wrong, yeah, that gives me something wrong. But let me check if at least the vertical walls, look at that, the vertical walls are all in the right place. Which means that I've messed up the horizontal walls. But interestingly, the horizontal walls aren't just, they're not upside down, and they're also not just, horizontally back to, oh, I see. They all moved up one line. The horizontal walls all, oh, of course that makes sense, because we're looking for the north wall. And once it's upside down, the north wall is actually at the north. So we just remove this -1. And that should fix it, right? Ladies and gentlemen, we have the mazes. Woohoo! Time to party. Time to celebrate. Okay, the mazes have now been generated. Okay, now we need to put the labels in. The B, W, Y, and the... This is a bigger chore than I expected, but I am enjoying it. So let's do it. Okay, so we are going to create a two-dimensional labels array. Let's see. Yeah. Wait, why does it say 8? This is interesting. Why does it say 8? Shouldn't it say X size and Y size, right? It's very surprising that it would say 8, because in 3D maze it's 6 by 6, and in Mouse in the Maze it's 10 by 10. So why should it say 8? But you know what? I'm just gonna change this and hope that. So the rows are of course Y size. Why did that unindent? Thank you. And this should go X size. Let's not unindent that. And now, okay, so we want labels. Okay, labels. So let labels equals a new array. In fact, I think I want, yeah, I'm going to do this array from array 10 keys. Right, so this will give me an array with 10 elements, and then each of those elements is going to represent a row. Okay, right, and now I'm going to do another array from array 10.keys, and this is going to give me the columns. So I'm just going to call it column. And now what do we need? Well, okay, so if the column is equal to 2, it was 2 and 7, wasn't it? If column is equal to 2, then if row is equal to 2, then now we want the color of the top left torus. Right, and the color of the top left torus, if I go back here, right, in torus color, it says clockwise from top left, sorry, it's not torus colors, sphere colors, of course, right? We want them clockwise order from top left, which means that at 2, 2, which is the top left, we want the first one, which is mazes of maze dot torus colors sphere colors of 0. Okay. Right. Else, if row is equal to 7, then see, I don't want to have to write this part over and over again. So here's what I'm going to do. I'm just quickly going to create a quick function which will turn an index. Yeah, that's right. So we want an index, and I want mazes of maze.sphere colors of that index, right? But I need to write that the old-fashioned way. There we go. But if index is equal to null, then we just want to return null. So all of the labels that are going to be blank are going to be null. So this is just going to be a 0, and then this is going to be a 1, otherwise null. Else, if column is equal to 7, then, yeah, let's do that. In row 2, wait a second, if the column is equal to 2, then row 2, right, row 7 is actually the last one, isn't it? Because it goes clockwise from top left, and column 2, row 7 is going to be the bottom left, so that's going to be 3. And then here in column 7, row 2, this is going to be 1, but in row 7 it's going to be 2, else null, else null. Right, and then we run all of that through our TR function. Why did that just disappear? Literally, Visual Studio just randomly disappears. Okay, let's try and recover that file that I was just working on, but I very much doubt that it recovered much. It did recover the TR function. It actually recovered everything up to here. Okay. So, right, this is missing a close parenthesis, so this should auto-format. So let's save this. But now, all of this code, I want to run all of this code through the TR function that I just wrote. Okay, this time it lets me paste that. Okay, and now labels can go here. Phew. So that should work. Let's refresh this. We have GBWY. Look at that, they're all in the right places. Now, here's something that I'm confused by. Oh! See, I was going to say I was confused by the fact that the torus is there, because I didn't tell it to draw the torus in the middle. But of course the reason it's there is because we have an error. So sphere colors is not a function. Whoops, why would it think it should be a function? Yeah, so that should just be an array index. There we go. So now let's run that, and of course everything is null. Does it actually literally say null? Yeah, it literally says null everywhere. That is very surprising. But you know what? I can just... there we go. It wants you to put a space in there. Okay, so I'll just put a space in there, and then all the nulls go away. Okay, now we have the number 0, 1, 2, 3, which of course we want to turn into... Let's see. We have... Oh, we're not actually in... No, we are in Mouse in the Maze. Let's open this file, please. So it's WGBY of that. Alright, let's save that again. Okay, let's see. So that is correct, that is correct, that is correct. Okay, so now they're all correct. And the fact that the toruses are gone makes me confident that it is working, because, as I said, I didn't tell it to generate the torus. So let's actually look at the original manual and literally just copy. Oh, interesting, it has two circles. Ah, I see, the inner circle is, okay, I'm going to change this. Yeah, I'm going to change this, because what this does is, what this does is it draws a full circle like this, and then it puts a white circle on top, instead of just drawing a circle with an outline, which is what I'm going to do. Right? So the difference in the radius is 3, which means that I get the same result if I change the stroke width to 3 and the stroke to that, remove the fill. And now, of course, the radius would have to be 9.5 to generate the same result. Let's delete that circle. And in my opinion, that looks very much like the original. So now let's literally just copy that and put it here. No, not here. Here. Right, create 2D. This is why we had the extra in the code. See, I was wondering what in 3D Maze was the extra thing, but of course the 3D Maze didn't need any of the extra. Actually, that's not true. 3D Maze had the embellished sheets. But anyway, I'm just going to put the circle right here, and it doesn't even need an interpolated string, because it's literally just a constant. Yeah, so let's just put that in there, refresh this, and we have the torus. Okay, it seems that our torus is just very slightly bigger. I'm not quite sure why that would be the case. Half of 3 is 1.5. But you know what? It's not that big a wait. I only subtracted 0.5. There we go. Now it's exactly the same size. Okay, ladies and gentlemen, we finally regenerated the original rule seed 1, and now we can literally just plonk the rule seeded mazes into that code. So here we go. Let's do that, right? So all we need to do is just translate this code from C# into JavaScript, which I'm going to do now, and hope that Visual Studio doesn't crash on me again. We want to generate 6 random mazes, and then remove. Yeah, that's right. So I'm going to have a mazes array, to which we're going to add each of these objects. And I would like to change all occurrences of var to let. Thank you. So for each of these mazes, okay, so this one here, so we want this as a string representation, don't we? So I'm actually just going to make this. Yeah, remember that function that we created? What was it called? Generate array. Turns out we don't actually need that anymore, right? We're just gonna pass it in as a string of zeros and ones, and that's gonna be fine. So this is going to be a string of what is the easiest way to generate a string of 91s in JavaScript? I have an idea. I'm just going to let's see if I can do this. If I do array and then 90 and then map true, do I get? No, it still says empty slots. Yeah, so I don't know, keys, I guess. I said keys. .map is not a function because okay, so I typed a close parenthesis there. Okay, so that does work, but that gives me an array rather than. Yeah, but I think that's what I'm gonna do. I'm just gonna have them all be one, strings with a 1 in it, and then I'm just gonna call .join on the array at the end. So let's do that, right? So that will give me an array of 91s. There you go. And we want that twice, so we don't need this anymore. Now to do, this is going to be the numbers from 0 to 100, which we can do like this. It's literally that. and visited is going to start out as an empty array. The starting square is going to be rnd.next. Yeah, I need to replace all of the next with lowercase next. There we go. Okay, so here add needs to be push, right? So wherever we have an add, we're going to change that to push. There's going to be a new array. Remove is going to be is there an array remove function? Remove. Yeah, no, there isn't. You have to find where the starting square is in the array, and then that is annoying. Now in this case, fortunately, we know that it's going to be at the right index because the to-do array is in order. So we can actually just do this. We just splice that out, and that will remove one element at that position. But we won't be able to do, we will be able to do that here, but not here. Right, this is where we need to do something else. But anyway, so while the length of to-do is greater than 0, pick a random square from visited. Okay, so visited has a length. So we get the square, and then we calculate the valid neighbors. So contains, I believe in JavaScript, is called has. Okay, why is that suddenly black? It just occurred to me that maybe I want to close Unity. I probably should have checked the memory usage before I closed it, but anyway. Has does not appear to be there. Includes, that's what it's called, right? Does that include A? That's a true. Does it include B? That's a false. Okay. So, contains becomes includes. Boink, boink, boink. And then this becomes push. Okay, now valid neighbors, if we don't have any, then we remove at that index, which we can do like this, right? We just splice at that index, splice out one element from that array. Next, we need that to be a length, and then if that is equal, math.min. Does JavaScript have a math.min? Yes, it does. Let's see if that does what I expect it to do. It seems to work. So I'm just going to use that. Okay. Now in this case, obviously, we're not using booleans. We're using the zeros and ones string. So I'm just going to turn that into a 0. Remove. So this is where. So the we need to find where in to do that neighbor is. Right, so let's see, to-do.find index get not to-do, sorry, I meant something like this, right? Find index. Let's see, that gives me why does it say A is not a function? I see. Find is probably the one then. And still, okay. Oh, index of, that's what it's called, right? So that gives me a 0, and that will give me a -1. Okay, so index of is what I need. So find me the index of the neighbor in there, and then splice that array at that index one element. There you go. Which means that we can actually inline that. So we didn't even need that much code. Okay, so that removes the neighbor from the to-do list. Okay, I think that's good. Num_wals to remove. Yep. And this code is just going to stay exactly the same, isn't it? Right. So this needs to be, let's see. So the first index was 10. Now, in what order did I output them? I need to make sure I get this right. Did I remove the code at the start of start? I did not. Very good. That's right. Okay, so I did them in reading order. So the first index is the x coordinate, which means that here I want I plus 10 times j. Okay, that should work. Right. And of course we don't want false, we want zeros. Okay, I can do that, I guess. And here, right, I'm gonna treat this differently, but we definitely want the arrays here. We use rnd.shuffle-fisher-yates on both of these, and then we use array from array for dot keys and shuffle that. Yeah, that should be right. Okay. Now, I don't want to add this to anything. I actually want to, I'll show you in a second what I actually want to do. I want to create one of these objects, right? So I have my mazes array, and I'm going to push an object with each of these properties. Okay, so h is going to be the hwalls.join, like I said, and v is going to be the vwalls.join. Right, and then this one here, great, now I've forgotten which one came first. Right, I think at this point I can really remove the temporary code. The one that was generated first is goal from Taurus. Right, goal from Taurus is this one. Put that there. Right, now that needs to be up, because that needs to be generated first, and then the sphere colors are generated after that, and the torus order, that one needs to be generated last, because the C# code doesn't generate that at all. Okay, so with that we should now have our mazes array, and then we can literally just set mazes. And now I am really curious to find out if this works right out of the box. Here we go. Ladies and gentlemen, refreshing the page at rule C2 in 3, 2, 1, now. Wow! It works perfectly. Okay, so what went wrong? I don't know. The maze generation did work in C#, so drum roll. Yeah, unfortunately not a party this time, or at least not yet, but yeah, ready for shipping. Okay, well, I'm going to take a look at this. So let's actually output the hwalls and the vwalls. Console.log hwalls and the vwalls. And I strongly suspect that those are probably fine. Oh, sorry, I should probably .join them. Right, .join. Alright, so let's run that. Aha, they are not actually fine. Okay, that means that this formula... Oh, I'm an idiot. No, I'm not an idiot. I'm not an idiot at all, because this is actually an array from 0. Right, okay, so I and j, so that the maximum of that would be 80 plus 9 is 89. This is... okay, this doesn't explain the observation, but I'm just going to make sure that this is more correct than it was, but it's still going to be broken. Okay, so it seems to generate only part of the... okay, it's this part that's broken. Yeah, because we have a comma here. Yeah, we need that to be plus 10 times that. Right, plus 10 times that. I hope that this works. It's still not working. That is very strange. Let me take a quick look at the C# code. Let's see. Okay, I'm going to have the C# code output the walls. So maybe I should actually restore this and just copy this and then get rid of that again. So here, after this, right, I'm going to output h is equal to this, and that would be hwalls, and then we have vwalls. right? That should be fine, and this is V. Okay, and now let's run Unity again. Here we go. Now, if Unity, like if the C# version of the code also generated the same kind of nonsense, then I'm quite impressed that I didn't notice this. I think I'm still on rule seed 1. So let's change it to rule seed 2. Here we go. Okay, so the first H is this. Whereas in the JavaScript, it is this. That is definitely not the same. It's not even the same length. Okay, one of these should be... Aha! Okay, so the first one, the JavaScript, the C# one, has the correct length. The JavaScript one is one item too long. Why would that be the case? Why would it have one character extra? That is very bizarre. What about the vertical one, which is obviously wrong because it's all ones? Yeah, that one at least has the right length. Okay. All right. Let's take another look at where we set the walls. Right. So here we generate a single array of 90 elements, which is exactly what we want. We want 9 by 10. So I think that part is correct. And then here, when we take out... Oh, I know why. Oh my lord. Okay, so this is JavaScript being annoying again. The problem here is that this division, or any division in JavaScript, is always floating point. So I need to use this trick to turn that into an integer. And, well, I say trick, but, you know, I didn't come up with that trick. Hopefully that should be fine now. Okay, that looks a bit more reasonable, especially this one. Well, actually, all of them look reasonable. It's just a bit strange that you have all these sort of comb-shaped... But they are definitely spanning tree mazes with just a few walls removed. So I'm tempted to say that this is working. So let's actually test this. Let's test this in the game. Drum roll, ladies and gentlemen. Okay, so I've already run this under rule seed 2. So we have a maze here which has a blue sphere in a right turning corner. That one. Okay, so this, let's see. See, it can't be this one because I can only go one step away from the blue sphere. So it must be this one where I can actually go 2 steps. But wait, no, that okay, it doesn't seem to... Yeah, no, so none of them is actually... See, okay, so this one here is in a right turning corner, but I can only go 1 step away from it. So I guess I'm gonna have to check the zeros and ones again. Okay, so here's what the first maze is in C#, and here's what the first maze is, or rather the horizontal. That seems to be correct. Right, let's try the verticals. C# and JavaScript. Okay, they also match. So that is very interesting. So why would the... Okay, so maybe it's just the wrong sphere color. That's always possible. But we did put the correct sphere colors in the vanilla mazes. So sorry, in the rule seed 1 mazes. So it's unlikely. It's just unlikely. Okay, so I'm going to let me just see if the shape of this maze fits. Okay, so we are... Could it be the spheres are different? Yes, that could be the case. But let's first of all check if the maze actually has the same geometry. It says you're in the middle right maze, so it would be this one. And I'm apparently in a dead end, right? Because there's a wall, wall, wall. And then we have 3 opportunities to move left, and then immediately a wall after that. Where do we have that? Let's see. We have that here. No, but here we could also move to the right. Where else? This? No, because there are only two opportunities. Yeah, okay, so in that case, it seems that the maze geometry does indeed not match, even though the zeros and the ones match things. So, okay, so I'm tempted, honestly, to go through this entire maze manually and map it out. And draw my own maze. And I've already got my Inkscape here. Oh. Okay, Inkscape just disappeared and I didn't save that file. Thank you, Inkscape, that was very helpful. Okay, I'm going to redo this though. I'm a patient person. I can deal with this. Alright, let's do this. And let's create 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then horizontal lines, right? So let's do this. Okay, what's going on? Nothing is using extreme memory, but Inkscape just disappeared again. That is very strange. Hello? I started Inkscape again. Is it not Inkscape? Okay, it is actually running, but it's not appearing. Okay, so I seem to be experiencing some problems, and I think the reason these problems happen is because Unity sometimes has the habit of allocating absurd amounts of memory. And after that, tons of other programs just start failing. I mean, you saw Visual Studio failing and you saw Inkscape failing. So I think that's what's happening. So what I'm actually going to do is I'm actually going to reboot my PC. Let's open this up again. Okay, so I really do apologize for this, but now I'm going to map out the maze in Inkscape. So let's do all of this again. We want a stroke of 1 pixel. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bit of a shortcut there. Okay, so we don't need that line, obviously. And then we do the same thing again. 2, 3, 4, 5. Let's duplicate that, put that here. Okay, that should be fine. And now I'm going to save this, just in case. Replace my temp file, Timway Professional, Inkscape Professional. I'm not quite sure what you mean by that. Alright, so let's map out the maze generated by Inkscape, by Unity, by the C# code rather, for Rule C2. Okay? By the way, I brought myself another one of these snacks. So I do apologize. But, okay. So this is supposed to be the top right maze. Okay. Let's do that. Okay. And the torus is green, right? Gold sphere, right? Green, green. Top right does top right have green, green? Oh, it doesn't even have that. Okay. Do any of them have green, green? Right, this one does. Okay, so maybe they are just misnumbered. That's entirely possible, I suppose. Okay. Okay, I can't think off the top of my head why the numbering would be off. Oh, wait a second. The torus and sphere colors would be off if the maze generation was off. But anyway, let's get on with this. I'm going to try and can I detach this tab? Can I like turn it into like bingo, I can. So it's but if I minimize Unity, then it disappears. Great. Okay, you know what? In that case, I'm going to keep switching back and forth. Let's put this back here. No, that's not really where I want it. I want it here. There you go. Okay. All right. So let's get on with this. So let's find a dead end somewhere. Or the green sphere. I guess that works too. Okay. I found a dead end. There we go. Tell me, how are you able to survive with only one screen? I don't know why people think they need two screens. I mean, I understand that if you have two screens most of your life, then you get used to it and you start making use of it. That's a bit of a show-off there, Livia. You definitely don't need three. But I have found, like, okay, see, I'm relatively old. So when I was young, having two screens was, not normal. Or even not possible, right? PCs only started having the ability to have two screens in, I think, the mid-2000s or something. So by that time, I was already firmly used to using one screen, and honestly, I was never looking forward to having more than one screen. I was rather put off by the thought. Like when I actually tried using that, which I did at work, I found it to be more distracting than useful. Right. Okay. I think you should be glad that I have only one screen, because if I streamed both screens or two screens, my stream, the text on the stream would be unreadable, and everything would be tiny, and it would be a super wide video. I think, in terms of streaming, it's definitely a good idea to have only one screen, or to stream only one screen. So, we're gonna start in the corner here. And we can move forward 2 steps, right? And then we can turn right. And then we can move forward, and there is no wall here, and then there is no wall here. Okay, now here, right, let me, hang on. Okay, I should be in, wait, where am I? Oh god damn, this is so hard. Alright, let's go back to the dead end. So I went 2 forward, right, forward, so now I'm here, and then left, so now I'm here looking north, so now I'm here looking east. Okay, right, that means I can go here, here, and here. Right, all 3 of these are available. Now here we have right, so the green sphere is here. So let's put that there. Remove the stroke, add a fill that is kind of greenish. There you go, and that's where the green sphere is. And then behind the green sphere you can turn to the right. And there's a dead end, perfect. So coming out from the green sphere, I can see the yellow sphere off in the distance. Now we know that this is supposed to be, so I actually, just by pure coincidence, actually started in the corner. That is extremely useful. Okay, so all of these walls here, or rather all of these horizontal walls rather, don't exist because I can see the yellow sphere. But then behind the yellow sphere, right, there is, okay. So now I'm standing on the green sphere. I can see that there is a wall here, but not here, here, or here. So each of those, there are 3 opportunities to move left. Okay, let's go here. The first opportunity to move left allows me to move left 1 more, and then there is a dead end. Alright, so let's back out of that. And now I'm going forward, and here, aha, there is a corridor behind the yellow sphere. So this one here goes down to here. That makes sense. Ah, and that one is also a single step dead end. Okay, so after the yellow sphere, I can move left, and that's also a dead end. Okay. And that means the rest of the maze must be connected from this square here. All of it. Okay, so going down this corridor and then turning left puts me here. Okay, so here I can turn left. I can see a wall here, and then here I can turn left again, and then this is the front wall that I'm looking at. I can also turn right, and there are two walls to my right. So this is as much as I can see here. So let's move forward and look left. Aha, there is a corridor going down 1-2 steps. So that's done. And then here I can turn right and then right again. So that would be here. And that goes 2 steps and then left. And that's a dead end. So that's interesting. So the rest of the bottom there is connected through another way. Okay, so it makes sense that I would be seeing the torus here because I'm now here, which is basically the middle of the right. So this is where the torus is, except that it's not filled. It's kind of gray, and of course it's maybe 20% the size of that. Might be a bit too small. Let's make it 40, I guess. Okay, so that's the torus. Okay, so I can see that at the torus I can move left, and I can move right, and behind that there is also no wall. But let me first see if I can go here. No, I cannot. So these two walls are definitely there. Alright, let's turn left at the torus. Aha, that's a dead end. Yep, that seems to fit. Okay, then here I can see that I can move right and then forward. Okay, so here on the left I can see the blue sphere, but I think I'm going to explore this part first. So I'm going down here and then left and then forward. So this is where the white sphere is. Okay, let's make that white sphere kind of gray, I guess. There you go, that's the white sphere. Okay, so I can go forward here and then left. Oh, I totally forgot about it. Ah, but it won't blow up because it's the test harness. Okay, so I guess I'll just deal with this and hope that it ends soon. I really should have activated Zen mode. Okay, so here's the white sphere. I can let me move forward first. So I can actually go all the way to the bottom of the maze, and then I can only turn right. Ah, bingo. So that takes me, let's see, 1, 2, 3, 4, 5, 6, right? So 1, 2, 3, 4, 5, 6. That is perfect. Right, so let's see. Only here can I turn right. Ah, but then in there I can turn left. And then that's a dead end. Yep, that makes sense. Okay. So that is not a wall. Okay, and now at the white sphere I can turn left, and then there is a dead end, and that would be here. Very good. Okay, so the bomb has exploded, which means it'll stop flashing, which is good because I don't want it to. Alright, so here we are now here at this point and looking forward. Let's see. I think there is another space there, right? Let's see. If I move forward and then left, I am here. I can see the torus, right? And then if I move forward, there's another space in front of me, so that shouldn't be a wall. But now let's see what's on the left here. Obviously the torus is there. I think I can see all the way there. And okay, so this wall is definitely there, but that one is not. And that one is not. Let's explore this part. Okay. Ooh, there is quite a lot there. So this is not a wall. this is not a wall, and that is not a wall. Okay, so if I move forward and then left, that is a 2-length corridor. And then here, okay, so now I should be here looking forward, which means that if I have not made a mistake, this wall is not the top edge of the maze. Let's look at the left here. We can go 2 steps forward here and then turn left and then right. So that means we are now here. Forward, left. Okay, now I'm not sure if I did this right. I want to get this right. So let's go back to the blue sphere just to be sure. Okay, so here's the blue sphere. I think... Oh, wait, I never actually mapped the blue sphere, did I? Okay, I'm a little lost. But I know where the blue sphere has to be, right? It has to be here. This is the only place that it could possibly be. So I think I'm just gonna map from here. So let's just go back to the blue sphere. But I don't know which orientation I am in now. Okay, so this is a bit embarrassing. I can see the torus there, so let's actually just try and... bingo. Okay, so now I'm north of the torus. I'm right here, looking forward. Okay, that means that this is not a wall. Okay, so I can go 2 forward, and if I look to the right, do I see exactly this? Yes. Right, to my left is this wall, and then to my right is this wall, and then in front, that's that wall. And then I can go left, and then I see the white sphere. So this seems to be fine. So right now I am here, looking south. Right, so now I should be looking north, which means that I can see the blue sphere, so that's not a wall. So now I'm looking east. I can go forward 2 steps here, right? 1, 2, yeah. And there's a lot of not wall everywhere. Quite a lot of, like, even to the right of the blue sphere, there is not a wall. Okay. Let's explore beyond the blue wall, right? Now I'm on the blue wall. If I go forward 1 more and then turn left, aha! Okay, so that part of the maze connects, and that does look like what I have here. So I think I'm done with that part. Right, there's no opportunity to move right, to turn right. Okay, I'm now here looking south, which means that if I go like this, I should now be here looking south. Let's see if there is a wall to my left, the green spheres to my right, okay, and there's a wall behind me. No, there is not a wall behind me. I can actually move 2 steps behind. Okay, so on my left is a wall, so that would be this one, because I'm looking south. And to my right, I can go 1, 2, 3, 4, 5, 6, 7 steps. 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7. It doesn't go all the way. So maybe I missed something here. Okay. Wait, why can't I see the blue sphere? I should be... okay. I guess this wall is enough to obscure it from this point, right? But if I'm here, I can just, like, if I'm here, you can see how when you move forward, it just barely sort of flashes into view. Okay, so I can move left here, which means that that is open. And then here I can move left again, which would be up. And then here I can go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That is the entire maze. The entire length of the maze, rather. Okay. So now I'm here looking west, going forward, turning left. I'm now looking south. I can go forward 2. I'm now here. And then here, I'm here. And then here, I can turn right. And I expect that to be a dead end. Yes, it is a dead end. Right, and then I can go 1, 2, 3, 4 steps more. 1, 2, 3, 4. 1, 2, 3, 4. Perfect. Okay, so now let's go back to the yellow sphere to see if I missed something there. So here's the blue sphere. We are now here. which means I want to go here. Okay, so now I'm here looking at the torus, which means I'm gonna go past that and look at the torus from here, and then I'm gonna go forward, left, forward, right. So now I'm here. I'm gonna go 3 forward, 1, 2, 3, and there's the yellow sphere. Okay, there was some lag there, but there you go, yellow sphere. Let me just quickly check memory. Oh my gosh, 27 gigabytes. Okay, so now you know what I mean. Let me quickly save that file before Inkscape disappears. I don't think you ever fully navigated the corridor that starts north of the blue sphere. Okay, that is possible. So here's what I'm gonna do. It's really frustrating that Unity has this bug because it makes it, it means that I had to close the game. So I'm going to make sure. Let's go back to the C sharp, right, top right. Top right. Ah, there we go. So top right should be number 1. So I'm going to change this to a 1, and then it should take me back to the same maze. Let's run this and hope. Ah, bingo, I'm right at the blue sphere. Okay, that's useful. Let's go back to Inkscape. Okay, so I am here looking west, I believe. Which means that if I go here, I'm still looking west, but I'm now here on top of the blue sphere. I can go 1, 2, 3 forward, so I'm here, and then I go left, forward, right. Aha, you were correct. I did not explore this part. So I can definitely go right, forward, left, and now I'm looking through here. Right, there's clearly at least 2 steps I can go. 1, 2, aha, I can go 3 steps. And then here, there's probably gonna be a dead end there. Okay, so now we have finally explored the entire maze. And let me turn around. Yep, that is definitely a dead end. Okay, and now I'm going to close Unity just to make sure that this problem doesn't happen again. And now let's see which one of these mazes is the most similar to the one that I just mapped out. It seems to me that basically none of them is. So which one would you guys say is the most similar? Aha! This one here? No. No, 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 no. Yeah, it turns out that none of them is similar. Unless... See, what I'm looking for here is like maybe a rotation or a mirroring or something, but it doesn't look like they are similar at all. So that means that there is a discrepancy between the 2 algorithms, and that is very strange. They both seem to generate valid mazes, and yet not the same mazes. So let's take a look through it. I thought that I understood exactly how the algorithm worked, and I guess I don't. Right, let's put that here. None of them, those long corridors on the east and north, are very distinct. Yep, I agree with you. None of them were similar. Okay. So we want to generate 6 mazes, and okay, let's compare them step by step. Right, start of rule seed code. Here we go. So we get the random number generator, which starts out right here. I'm gonna go for a quick bike ride. That's fine. Go ahead and have fun. Enjoy your bike ride. Right, so for each of the 6 mazes, right, we generate these walls, which, this is not part of, like, that doesn't use the random number generator. We fill the to-do list. That works. We have a visited list. We have a starting square. Now that, this is something that we can actually check. So I can say debug.log format starting square for maze thingy is yeah, some value. All right, and we'll just say maze index and starting square. There we go. Let's output all of those, and then of course in the JavaScript code I'm gonna do the exact same thing. Where it decides on the starting square, I'm gonna say console.log, put that there, starting square for maze index, no, is starting square, like that. Okay, so now I refresh this page. Oh, maze, yeah, okay. Thank you. Okay, shall we also remove these for now? Let's get rid of these. I can always write those lines again. Alright, let's compare those. Here, I think I want to remove those lines as well. Here, these. Right, let's remove those and run that again. Okay, so we have 81, 88, 20, 29, 0, 97. 81 is correct, but then after that it's out of kilter, presumably because the maze generation algorithm for the first maze ran into a discrepancy. So we need to find out where the discrepancy is. Okay, so the starting square is not where the discrepancy is. So we can remove that log message. Okay. So, is it because of this? Is it because because here in C# I say remove, you know, let's just try that. If I just change that to a remove at. Let's see if that just magically fixes it. Oh, I should probably put that back in so that I can see what the starting squares for the following squares are. Okay, for the following mazes rather. So let's put this back in. It's still 81, 88. Okay, so that didn't make a difference. Okay. I'm gonna keep that there because that's a good way to recognize whether they're now in sync or not. Okay, so random square index is 0 to visited count. Square is equal to visited random square. Valid neighbors. Ah, okay. Oh, there we go. It's that thing again with the division by an, you know, the integer division thing. Right, that needs a close parenthesis. Okay. Now let me quickly check if there are any other places where I do an integer division, because I think right here, nope, that is all modulo, no integer division, so that should be fine. Let's see if that was enough to fix it. No, it was not. It's such a disaster. Okay, so let's continue then, I guess. So let's see if the valid neighbors. Wait, if the first square is 81, which is that on an edge? That is on the bottom edge. Yeah. You know, because it's 10 by 10, you can literally read the coordinates from this. So 81 would be 8th row and then first column, but of course it's 0 based, so it's actually the 9th row. Oh, it's the 9th row, so it's not actually at the bottom. Okay, that's a bit of a bummer. So we fully expect the valid neighbors to be just all 4 of them. Okay, let's see. Yeah, and then we just remove that. The random square index was indeed an index into visited, so that should be fine. And then we select one of the valid neighbors. Get the neighbor. Oh, look at this. Never mind. Nope. No, I misjudged that. Okay, so if that is equal, so maybe this is wrong. Um, I think I took pretty good care here. Um, let's see. So this is an x coordinate and this is a y coordinate, and then here it's swapped, right? This is a y coordinate and that is an x coordinate, but that's exactly what we want, right? This is going to be a number from 0 to 9, and then we do 10 times something that is going to be a number from 0 to 8. Now, why would this be a number from 0 to 8? Yeah, that's actually a good question. Ah, okay, I see. Yeah, of course it would be. Um, yeah, that's right. Okay, it's because it's math.min, right? So one of these is going to be one less than the other. And so, yeah, so that all checks out. That seems to work. And then we add that and we remove that. Is this wrong? I don't think it is. Dot remove. Yeah, I'm pretty sure that removes only the first element. Okay, I cannot currently see the discrepancy. So, in that case then, I'm going to output a string that will tell me exactly how everything happened. Okay, so I'm going to generate a string. Oh, this is not the C# part. This is the C# part. So I'm going to generate a string. In fact, I think I'm going to start with this here, and I'm going to append start equals, let's see, append format I can use. There you go. So that would be the starting square, and then semicolon. All right, now for every iteration of this, I'm going to add something to the string that tells me. So first of all, I'm going to output this random square index. All right. So random square index, which is also a number like square. Okay, and then I'm going to output something here to say there are no neighbors. I'm going to put an exclamation point for that, for no neighbors. Okay, there we go. And then when there is a neighbor, okay, so when there is a neighbor, I have an index and a neighbor, so I'm going to say comma, neighbor index equals that, so the neighbor index is the neighbor. Right. And then we will hopefully be able to figure out the discrepancy. So here I'm going to debug log the str. There we go. And then on the JavaScript side, I'm going to do the exact same thing, right? So here at the start, for the starting square, right, let's say let str equal to this, right? Let's start with this, starting square. There we go. And then here we have that. Well, rather we have that. Okay, so str plus equals that, except we're going to make that an interpolated string. Put random square index here and then square here, like that. And then a dollar in front. There you go. Okay, so that's that. And then here, if valid neighbor.count equals 0, I'm going to output an exclamation point. There we go. Otherwise, I forgot to put a semicolon here. Right, so that basically goes after this. Right, and we want str plus equal that, where 0 is, of course, that, and the 1 is that. Okay. Right, and then at the end of this loop, I want to output the str. Okay, now I'm really, really curious to see what happens. So for the first maze, we get this long blob. And in the C#, we should get something very similar. But not identical, because if it were identical, then, you know, then we wouldn't have a bug. Okay, so here is the C# version, and here is the JavaScript version. So, let's see. We start at 81, and then we do this, and then we do this, and then we do this. So let's see where the first discrepancy is. It seems that the entire first line is correct. Second line, third line, everything up to here. Aha. So the entire first maze is correct, which means that the discrepancy must happen at the last step when it decides some walls to remove. That is interesting. Does that mean that this is wrong? I kind of doubt that. Okay. Okay, so I need to figure out whether this index is the same as this one. I thought it was, but let's take a quick look at this one here. Yeah, that does seem it's the first one plus 10 times the second one. This is the first one plus 10 times the second one. As far as I can tell, that should be fine. So let's just add that to the end of this console string, and we're just gonna say removed. So HV means horizontal, else vertical, at I and then J. Right? I do want a dollar sign there. There you go. So let's put something similar here. That would be here. So here we say string the SB dot SB. What did I call it? Oh, it's str is what I called it. Str.append format. Let's see, we want removed this semicolon. Right, and we removed that, and then ij. Now let's see if that becomes discrepant. Okay, so let's refresh this, refresh that again. Let's find the first one, which is this one. So this is the JavaScript. And then here, hopefully, let's take a look at the memory usage. Okay, so right now, Unity is still being reasonable. Let's take a look at this and put that here. Okay, so after all of that, we remove exactly those two walls. That is exactly the same. Right? It's H18 and H72. That is what it says here. Okay, and then for the next... Oh, my word. I've figured it out, ladies and gentlemen. I know what's going on. You see, here in the C# code, we generate the go from torus and the sphere colors, but for the manual, we also generate the torus order. And I thought that I could safely do that afterwards because it would be at the end of everything, but of course it's not, because it's still inside of the loop. So, what I'm going to do is I'm going to add a redundant thing here. There you go. This is redundant for the C# side, but the manual side does this. to randomize the order of the torus colors in the manual. Yeah, we already talked about the manual. Okay, so this finally should give us consistent start values. So we have 81, 54, 5, and then 53. 54 is correct, 5 is correct, 53 is correct, 4 and 38. Ah, finally. Okay, cause to celebrate. Okay, so that means the mazes in the manual haven't changed, the one on the module has changed, which means that I can probably trash this here now, because that's huzzah! Thank you, Jasons. Okay, so let's see if I can actually solve this module now. We have a blue sphere that is right next to a T corridor. This one is on a T junction. This one is right on a T junction. This one is next to a T junction. This one doesn't fit because it's in a corner. This one doesn't fit because it's next to a sort of empty space. This one kind of fits. Let me place myself on the blue sphere and see if that fits. We have 3 steps in one direction and 2 steps in the other. No, this one has a long corridor, so this is the one. So we have 2 steps in one direction, and yeah. So how do we get to the torus? Well, we go here, and then now we're looking south, and now we're looking west. Okay, so the torus is white, so we expect the white sphere to be the goal sphere, and it is! Alright, let's see if we can actually reach the white sphere. We need to go just before the torus, turn left, forward, left. We are now facing east, forward, forward, right, and here is the... Okay, let me just submit here and get a strike, and here, that is solved. Ladies and gentlemen, it is working. That took longer than I expected, longer than I anticipated. I didn't have to write the code to generate the SVG, but the code to generate the maze really had me stumped there, and I wasted a lot of time on mapping out that maze from the module, which really wasn't all that useful. Now, I am a bit surprised by the fact that we do seem to get a lot of generated mazes with long corridors. That is not usually what this algorithm outputs. That is very surprising that it does that. Oh, look at this. Here we have one where the torus is in the middle of a... oh, I want to see this one. I want to see this one. This is rule seed 7. Let's go to rule seed 7. And I just realized that I totally forgot to change this. So I'm going to have to remember to change that, so that it doesn't always generate the same maze. But anyway, this would be maze 2, because they're 0 based. And let's go and let's find the torus. Okay. So I should be in a twisty passages with exits to the north and east. Wait, wrong module. Okay, aha, there is a white... Oh, there is a torus. Hey, I found it. Look at that. It's just hovering in the air. Oh, that is so cool. Hey, ladies and gentlemen, we found it. Okay, so I think this is now working and I can publish this. Alright. Thank you all very, very much for watching this stream. And as you can see from the bottom right corner of my screen, it is now 2 a.m. And as I said, I played badminton earlier, so I'm definitely both mentally and physically exhausted now, as I predicted I would be. But I thank you all for watching, and I really, really hope that you enjoyed the stream. And if you want me to stream more of this, please let me know. If you want me to stream something different, I'm happy to hear suggestions too. I am definitely planning to do more of the souvenir streaming, for which we have the wheel. Oh, why did I just erase that? We have our list of modules here for the for souvenir support. So maybe, just maybe, next time I stream, I might potentially add souvenir support for kanji, or maybe any of the others on this list. We will see. Alright, thank you very much for watching, and I really hope that you enjoyed this stream, and I'll see you again next time when it's time for another rule seed, another souvenir, or maybe something else entirely. Let me know what you want to see. Okay, thank you for joining, and I will see you. Goodbye.